Answer time for lesson 22-1. To check your understanding, are all isosceles right triangles similar? Yes. Because what kind of what are their angle measures? If it's isosceles, that means the two legs are the same size. And if the two legs are the same size, then these base angles right here are both 45. So they are similar by angle similarity. Similar by angle similarity. All isosceles right triangles. Two right triangles are similar with the scale factor of 3 to 4.5. The triangle with the shorter hypotenuse has legs 6 to 8. Well, I know how long the hypotenuse is. 6, 8, 10. And what is the length of the longer hypotenuse? So they want to know what this length is. So it's a simple proportion. If the scale factor is 3 to 4.5, write it as a ratio, and it doesn't matter which one goes on top, which one goes on bottom. Just remember that the big one, that's what I'm looking for. If I write this on bottom, then the big one has to go on bottom. And the hypotenuse for this one has to go on top. So all I have to do is cross multiply 45 divided by 3, and I get x equals 15. So that is how that one works out. Okay, so let's see, what is the length of the longer hypotenuse? We figured that out. Okay. Use this triangle. What is the leg opposite angle Q? Here's angle Q. I'm going opposite, so it's side RS. The leg adjacent to Q. Now this is gonna help you out, help me out. I'm labeling that hypotenuse because that's the hypotenuse no matter what. Okay, RQ is the hypotenuse. So as I ask about all these other things, as long as that one's labeled, it makes it easier. Okay, so here's angle Q. We labeled this one opposite, so the only one left is this one to be the adjacent. So SQ is adjacent. The leg opposite angle R. Here's angle R. Go opposite. SQ is opposite angle R. Okay, we went opposite already. Hypotenuse is marked, so we've used these two, so the only one left is adjacent. So RS. Okay, now let's see if we can make sense of this. We've got scale factor questions and find missing parts. Okay, pay attention to the order in which things are listed. That's going to tell you where to get your scale factor from. Okay, so CB is this leg right here, so I need FE. Well, there's FE right there. So FE and CB are going to be corresponding. So that means I'm going to take 6 to 12 and reduce that. 6 over 12 reduces down to 1/2. So we can say the scale factor is 2 to 1. Can you say 1 to 2? Yes. Well, actually, let's get it right. A is smaller, so we're going to start that's the one that we started with. That's the first one that's listed. So A changes into DF. That's kind of the way that I'm seeing it. So since A changes into DF, we need a scale factor of 2 to 1 to make it bigger. If we go 1/2, then we'd be going from here to here. But it truly doesn't matter as long as you write your ratios the same. So they want us to know how big is AC. We're going to call that X. And then they want AB. We'll call that Y. And then they want to know how long is DE. We'll call that W. Okay, so we're going to write a ratio of, you can use 1/2 or 2 to 1. We'll do it both ways to show you that it doesn't matter. If I use the scale factor 1 to 2 and I put the 1 on top, then anytime I use this a side that I'm looking for, let's say X, I'm looking for side X, then it has to go on top because the smaller number is on top. And then we have to pick a number from the big triangle that corresponds. Now remember, AC right here corresponds with DF. So DF is 13. So now to find out the answer, we cross multiply. 1 times 13 is 13. 2 times X is 2X. Divide both sides by 2. And it's half of 13, which is 6.5. So this side right here, AC, is 6.5. Okay, if we do find AB, AB is Y. Okay, so if we use the ratio 2 to 1 instead of 1 to 2, then all we do is have to be sure. Now we're looking for AB right here. AB is from the small triangle. We've got the small number on bottom, so Y has to be sure and go on bottom. And then the side that corresponds with Y, oh, we can't find that one yet because we have a variable missing. So we're probably going to do Pythagorean theorem right here. So 12 squared plus 13 squared is equal to W squared. And 144 plus 169 is equal to 313. And take the square root of both sides, and W is about it's about 17.69. So I'm going to say W right here is equal to 17.69. They didn't give me a rounding rule. So since it didn't give me a rounding rule, I can actually put the exact value as well. But for doing these problems where you're finding the sidelings, I think it's better to be able to change them to a decimal. It's more reasonable. We can tell the reasonableness of it better if it's a decimal than it is with the square root. Okay, so this one right here, while I'm working with it though, I'm going to go ahead and put the square root of 313 because I don't want to get a round off error. So I'm going to cross multiply, and I get the square root of 313 is equal to 2y, divide both sides by 2, and y is equal to, that is the exact value, the square root of 313 over 2. And then if we want that as a decimal, we just have to say the square root of 313 divided by 2, and it's about 8.85. 8.85. If you want an exact value, you have to do the square root of 313 divided by 2. So it doesn't matter how you do the ratio, how you set up the ratio from the scale factor. You do just have to be sure and make your ratios match so that the shorter side is the number that's on top comes from the smaller figure. This says that the number from the bigger triangle has to go on bottom. All right, this is one of those 45-45 triangles, so I can look at that. I can also use my special right triangles. I know this is going to be 8 square roots of 2, and this is going to be 12 square roots of 2, so I don't even have to do the Pythagorean theorem, but I can write the scale factor is 8 to 12. Reduce that down. Let's see, what'll go into that? 2 will go into 8 4 times. 2 will go into 12 6 times. So I can reduce it again. 2 will go into 4 2 times, and 2 will go into 6 3 times. So there's the scale factor. The scale factor is 2 to 3. And again, I would have probably written it 3 to 2. Should have probably written it 3 to 2 if we're starting with this one and we're going bigger. So 3 to 2 might be more accurate. I think that's the preferred one. So I've already found everything. UT is 8 square roots of 2. YZ. YZ was 12. And XY was 12 square roots of 2. And then this one down here, the last one, we've got the scale factor. We need corresponding parts. It looks like LM. LM is going to correspond with GH. So LM is going to correspond with GH. So there's the way I'm going to get my scale factor. Write those as a ratio and reduce. That'll go 1/3. I'm getting bigger, so I probably need to go 3 to 1. I'm starting with the smaller one. LMN is smaller, so 3 to 1. We need to multiply this one by 3 times to make it get that one. So that's pretty easy then to get, let's see, this one right here, 9.5, that's MN. So in order to get the corresponding side, which would be HI, we just need to take 9.5 times 3. So 9.5 times 3 will give you 28.5. And this one right here would be 28.5. And to get this third one, the hypotenuse, we're going to have to do the Pythagorean theorem for one of them. 2.5 squared plus 9.5 squared is equal to the hypotenuse squared, and that's 96.5. So you take the square root of both sides, and you get about 9.8. I don't have any problems rounding this one to 1 decimal place because all of the others have 1 decimal place. So I'm not going to worry with exact values here. They didn't give me a rounding rule, so, well, I didn't need one there because I could leave them in exact values. But here they didn't give me a rounding rule, so I was a little nervous about rounding it to 1 decimal place. But here they have 1 decimal, so I'm going to just follow that rule. So if this hypotenuse is 9.8, we got to multiply that times 3, and we get 29.5. This one will be 29.5 because all I did was take this and multiply it times 3. You could set it up as a ratio. This was 9.8, and this is 29.5. We'd use 1/3 is the ratio, and then do 9.5 on top over HI on bottom. Cross multiply, divide. That's where we got 28.5. After we found the 9.8, we do the same thing again. 1/3, or let's do it upside down, 3 to 1. So the 3 means the big one goes on top. We were looking for GI, so it would go on top because it's from the big triangle. And 9.8 would go on bottom. Cross multiply, divide. All right. So good luck with the rest of the unit. Trig is super fun to me. I hope you enjoyed it as much as I do.